All right, our next speakers are Robert Verhagen and Erwin from Verhagen. All right. Uh, and their talk is entitled iRODS-based system turbocharged next-gen sequencing analysis during pandemic and beyond.
Thank you. Thank you. We work at the RIVM, that's the Dutch National Institute for Public Health and the Environment. What we do there is making living in a safe and clean and healthy environment. We're preventing and controlling infectious disease, and we take care of good health care and healthy lifestyle. Uh, the left picture The left picture is where we now live. Just build a new building at the Utrecht Science Park, and next year we are going there. We work at the Department Bioinformatics and Computer Services. I don't know if everybody knows what bioinformatics is, but it is related to genomics. Genetics and genomics in a scientific subdiscipline that involves using computer technology to collect, store, analyze, and disseminate biological data and information such as DNA and amino acid sequences, annotation about and those sequences. We also we make a research environment for scientific employees and researchers, and we do the support of this environment, and we maintain have a data management system for unstructured data. Guess what the system that is? But we will tell something about the history. Why did we start? Our challenges and the environment that we make. We will tell something about the products that we made, the iRODS, job engine, bio-rods, and the archiving to serve. We will tell something about 2020-21 when the pandemic came, and they asked us to analyze the data that they done last year in half a week, if that was possible. Some other success stories and future plans. Bioinformatics is used in more and more places, also in the National Institute for Public Health and the Environment. For example, the spread of pathogens, the genetic population research, effects of lifestyle choices, the origin of genomic diseases, and the consequence of changing the living environment. So that's what the RIVM is doing. The challenges for bioinformatics data was it's a large amount of data, and the data should be fair, findable, accessible, interoperable, and reusable. Lots of computational resources are necessary to analyze the data. The data that is generated should be reproducible, and there should be a platform where people can develop and share the pipelines. Well, what we created is a bioinformatic platform. It's a shared Linux environment where they can cooperate and for creating bioinformatical pipelines. We created a high performance computing cluster with a fast lustre storage. We created a data management system for organizing the data flow. We did a process automation tool to automate the start of the pipelines. And we give some courses, for example, Git, Linux, HPC, and SnakeMake courses to make use of the environment.
So this is the infrastructure we came up with. You see our HPC clusters with workspace on the right, our iRODS data management system in the middle, and our data sources, which are sequencers, are on the left. Of course, we have some resources and some databases that control execution. But it's easy to draw up a architecture like this, but it's not very trivial what these arrows actually mean or how they are implemented. So we had to develop some things ourselves. For example, these sequencers, there are unreliable devices. They're in a lab somewhere, so you don't know if someone turns them on or off, and we still want to get the data of them automatically, and it goes into iRODS. And we also wanted to have some automatic analysis pipelines on our data. So we want to bring it to the HPC, do some calculations, get the results back in iRODS, and get some data provenance information stored. So to show how our results are created. And also we had a challenge with increasing data volumes. How can we archive that? So we developed some custom solutions for that. We're looking into existing things, but nothing really matched our use case. To get our data from the sequencers or other external sources, we developed iRODS. To run the jobs from the HPC for iRODS data, we had the job engine. We had the iRODS archive scripts to bring our old data to tape archives, and finally a web interface called BioRODS to manage it all and give our users an overview of what's in iRODS. There is something about this iRODS tool. It's a tool that can import data into iRODS from a variety of sources, from file systems, but also over network protocols. And it will do checksum validation right from the source. So you can even have like a file with the list of files and checksums. It will validate those against the objects that are put into iRODS. So we're always sure that we get the data correct into iRODS. It's multi-process, so it's to improve performance, and we use it already for a couple of years now. We have moved, I think, half a petabyte of data with it, and hundreds of millions of data objects. So it's very reliable.
And what is also a good thing is that sometimes, of course, those sequences restart, or we do a rollout and we restart things, but it just picks up, it does a checksum, millions of files sometimes, and it's always stable. So it's always going further, and everything finished, and then the pipeline starts. Yeah.
And also a good thing is this is now open source, so it's available on GitHub. If you need to get data from next-gen sequencers, but also from other devices, from anywhere, you can use this. Then our job engine. Well, we show here a basic data analysis process where you have the input collection, a process that runs on the data there, and some result that is stored. And how we implemented that in iRODS is when we want to run some process on our data, we start by creating an output collection. We attach metadata to it to point to the desired input collection, and also to the process that has to generate the output data, and some metadata to control the job engine itself. So this gives us basically two things. The job engine can query iRODS to see what output collections have to be generated. It will move the input collection to our HPC resource, start the pipeline, and get the data back into the output collection. And afterwards, we know exactly how this output collection is created. So we have provenance data. We know it's created from this specific input collection with this specific GitHub repository process and this specific commit there. So we can always trace back how our data is being generated. Of course, this process can be repeated because many times we have multiple processes running on data sets. We have a nice picture of this coming up. This is not available publicly yet, but we want to make it open source, so we're working hard on that. And then the challenge of managing the growing amounts of data. We reached out to the people at SURF. They have a service called RIVM Storage Scale Out, where you get an iRODS consumer server at their infrastructure, which is connected to their vast tape library. So everything you move to that resource will be moved to tape magically. Only thing where we struggled with was that we have collections with a lot of objects in it, and it's not very efficient to move that to tape. So we created some iRODS rules to pack those all in a tar archive, and also to get all the metadata that is on the data objects, store it in a JSON file, move it over to the SURF resource, and then we can remove the data objects from the source, because we have stored basically everything. We have the metadata, we have the data objects. It will reduce the size of our databases, and for long-term storage is a really good solution. That's very good cooperation with this from the SURF people. This is now active also, and we have I think now 800 terabytes stored. Yes, it's always a bit of a pity if you're presenting after the Sanger Institute, because they have so much more data, but for us it's a lot. Yes, so much more dark data.
We created a web interface for us just to look at the metadata and the data and the collections, but then also for the users. Now it's a tool for admins and for users to look at the data. It's a primary tool, so we like them to use it for everything because they get the data governance and the reproducibility. Well, there's a main menu and a traditional collection tree. The data graph, you can see which pipeline created the data and what has been done with the data. User actions, you can say if the data should be archived or not, and you can run pipelines directly on or a group of pipelines on the collection that you select. You can see your own metadata, and of course the content of the data. This is a better picture. So you can see that we have projects, and in so the data of the sequencer is imported. It is demultiplexed, and then it's spread over different projects, and all projects or users have their own project, and they decide which pipeline should be run. A little bit about data provenance. The blue collection is the collection from the sequencer, then the metadata is enriched, then the demultiplex is started, and the data is spread over some projects. The QC is the quality control of the sequencer. So it's connecting all of the runs of the sequencers together. But you can click on a collection and you can restart all processes. They can also view the reports in the browser, so they don't need to take out the data and put it somewhere else. Job list. It's just the last started jobs. The processes, so bioinformatics make pipelines, and they can add the pipelines to iRODS, and other people can reuse it. The use of this made it much more shareable, the pipelines. So first they are only making it for themselves, but now all of the RIVM are using it, and a lot of those pipelines also on GitHub, so other people are also using it. If you created a pipeline, other people in a project can select, for instance, the assembly and all of the other pipelines, antibiotic resistance or typing or whatever with that image. They can also add users and to the project. Everybody is able to see the metadata, but only the users can access the data. It is possible to search through the metadata, of course. Well, during the pandemic, before we had some data, they were telling us that it would be more and more and more. But as I've told, during the pandemic, they used nanopore, and this produces a lot more data than the Illumina sequences that we used before, and we got data from everywhere. So as you can see, it is, but yeah, it is 40 terabyte a month, and before it was under 5 terabytes. So it was a large scale up. It was we had everything in place. We had iRODS in place, automatic pipelines and so on, but it was a lot of data. So the problem was getting the data to the HPC and running it. So we worked for a month to optimize the import tool. We split up the raw data and the data they were really needed. And after that, it was possible. And well, we got the reports from the RIVM about the COVID pandemic. Success story, yeah, the scale up was made possible by iRODS. Otherwise, we could not have been doing that. We created a workplace for people to do research and production. So the research use the HPC and the environment because of the production. They don't need to pay for it or anything. It's just a spin-off and working together on the platform. The sharing of pipelines also externally is a success, I think. Automating the import and the starting of pipelines save people, of course, a lot of time. So yeah, they are very happy about that, of course. And the archiving to serve and having the data on one place instead of a lot of places is a lot of cost reduction in storage uses. What we are planning to do is well, not only bioinformatic data in iRODS, but all unstructured data sets to iRODS at the RIVM. We think that's a good idea. We want to use serve and cloud compute for upscaling our HPC. So automatically the job engine can decide, do I need to run it at serve or at our own place? We would like to share data externally because we have some cooperation with Wageningen, for instance, and we'd like to share the data on more easily way. And we'd like to make all of the code open source. Thank you.
All right, do we have any questions? We got, yeah, you already walking this way, so let's.
Hi there. A couple of questions about the HPC integration. What is the cluster manager that you're using? Slurm, LSF? It's LSF.
Yes,
okay.
we like to go to Slurm, but now we use LSF. Yeah.
Okay, super. And how do you prevent the number of workflows from overwhelming iRODS? So how do you restrict it in the HPC, or don't you?
Yes, we do. We have a priority queue, and that's for the production. We thought we needed more priority, so more important pipelines and less important. But for now, it's enough that we have priority queues for everything from iRODS. That's starting within an hour at the maximum, and users they get less resources.
And apart from that, we have limits set in the job engine. You can limit per project or per process the concurrent amount of workflow analysis running.
Thank you. Can I compare notes later?
All right, do we have any other questions over here?
Some questions on your tape archive. When you put things to tape, are they still available in iRODS then? So that somebody can ask, because obviously if you're trying to get something back from tape, there's a delay. Is that managed by the system?
There is a delay indeed, so it's, well, we can have different configurations. Sometimes we have a collection stored on tape and also still available in iRODS because we just want to have a backup copy. But some collections we guess will never be accessed again, and they are not available in iRODS except for the base collection, which still has the metadata, so that one is still findable. But if you want to retrieve the data objects from that, you have to give an active command to move it back from tape, unpack the tar archive, and re-register the data objects, which is all done in the iRODS rules, so it's not hard to do. You have it in the interface, you can just say, I want to have this collection back, and I want to be able to access it for the next month or 3 months or 6 months. Set the time limit, so it's not forever, but it's just a click of a button, and then you have to wait for.
What's the underlying tape system? What is the tape system underneath? Do you use something like Convolt?
We have
or
to
Backyard?
ask Surf. It's
Sorry?
not our tape. It's
Surf, but I think, Claudio or
So it's a proprietary system that, well, the acronym is DMF, the system, and that's what is exposed to iRODS. So that's how it works. So there are the rule mentioned that are able to query the tape library in terms of the status of the data in the tape and telling iRODS it's online, it's offline, and so on. So iRODS can react based on this.
And maybe a good thing to say is that if people want to run a pipeline on the data that is archived, then the job engine automatically picks up the data from the archive, set it online, and then run the pipeline. So nothing has to be done.
Hi, I'm curious, how long does it take to develop all this? How many people are working on it?
well, we started with 3 people. Team has grown a bit, but most of it is what we have shown. Is with, developed by 4 people. 18.
Just before the COVID pandemic.
Let's say in the end of 2020, we had most things in place. Gross of the development was in those 2 years.
Got a question over here.
Hello, I was wondering which cloud services are you thinking about using to store the sensitive data?
To store sensitive data?
Yeah.
Well, for now, we don't use cloud services to store
But in your
sensitive
future
data.
plans?
We only do it at Surf now.
We see Surf as a cloud provider, so we also want to use the HPC. Yeah, that's one thing we're working on at the moment, and I think that
I think we can do it at Azure also because we have some agreements there about sensitive data.
Yeah.
Don't know the English word. It's bewerkersovereenkomst.
Okay, thank you.
Any other questions? Any in the, oh, right up behind her?
So you said you hope to make this public soon. Maybe I missed it, but is there a timeline on that?
No.
And
All right, no worries.
we roll out everything in with I know we roll out everything with Ansible, and I saw that there are 110 roles for it, and we like to split up a little bit, just job engine as one thing, and that would be easier to make it open source. I think first we have to do that. So,
but
half a year, something like that.
I hope at the next user group meeting we have more things that are available.
Yes.
Okay, yeah, online question. Are rules invoked only by a change happened through the web interface, or are those PEP rules triggered by any client event?
everything starts with the data coming in from the sequencer. So when the data is complete, then it is automatically the pipelines are automatically start and everything goes on. But what also possible now, people can upload their own data because they get it from somewhere else, and they can say, well, start the pipelines on there. That's also possible. So that are two options, I think, for starting pipelines.
All right. If you have more questions, just let's
Can
save
do
it
it
for
offline.
after this. Let's save it for after. Thanks, guys.